So this problem says, what is the electric potential energy of the group of charges in this picture? And in the picture, we're given 3 charges and 3 lengths. So the equation that we want to use is the potential energy, the electric potential energy equals the sum of K times the charges over the radius. And so if we assign the numbers to these charges, then we have Q1 here, Q2 here, and then Q3 here. And then we have R1 to 3, and then we have R2 to 3, and then R1 to 3. Sorry, this one is R1 to 2. And then for this equation, we're going to want to add up the potential energy of the charges from 1 to 2 plus the potential energy for charges 1 to 3. And then we're going to want to add up the potential energy from the charges 2 to 3. So when we write that out, we have K times Q1, Q2 over R 1 to 2 plus K Q1, Q3 over R 1 to 3, and then K Q2, Q3 over R 2 to 3. And then once we plug it all in, we can take out K because it's in each of the equations. So we have 9.0 times 10 to the 9 over, and then once we plug in all the charges, Q1 is 1.0 nanocoulombs times Q2, which is negative 2 nanocoulombs, over R12, which is 0.03 meters. And then we add Q1, which is 1.0 nanocoulombs times Q3, which is negative 2 nanocoulombs, over R 1 to 3, which is 0.03 meters. And then lastly, Q2, which is negative 2.0 nanocoulombs, and then Q3, which is negative 2 nanocoulombs, and then over R 2 to 3, which is 0.03 meters. And then once we do all those calculations, then we get negative 0.60 times 10 to the negative 6 joules minus 0.060 times 10 to the negative 6 joules plus 1.20 times 10 to the negative 6 joules. And then once we add those all together, then the net potential energy we get is 0 joules.